Exactly. None of those rules change when the base is even. They just have to be the same. Now here, though, you could do this a different way. Log A plus log of B to the what power? -1. Well, what's that equal? When you add logs, what do? You multiply, right? But what's A times B to the -1? A over B. So it's the same thing. They are all results of each other. They're all results of each other. It's a self-contained set. Yes, but I'm just saying that you can get from here to here directly with that rule, or go from here to there. We never use that rule, we never use the division rule to get from here to here. We use the addition rule, but we also had to use that moving the power thing. Okay. We're cool so far?
I like this.
We're good? Okay, let's just chat about the homework real quick here. On homework 12, were there anything that struck you as weird or challenging? Anything you want to ask about? 1 through 36. Any questions? 32? Yeah. 32 is log base 5 of the cube root of 25. Many different roots. Log base 5 of the cube root of many different roots. What do you think I would do first on this? Someone want to vote on what I would do first? I would change something here. Yeah.
Exponential form?
You could. That's not what I would do, actually. You could, though. I hate cube root. What am I going to write it as?
25 to 1/3.
25 to 1/3, right. So let's just do this way, and then we'll go back. 25 to the 1/3. What is 25? What do you do with powers of powers? You multiply them. Thank you, Dawan. And when you have a power, what do you do with that power? 2/3 log base 5 of 5. What is log base 5 of 5? So what does it turn into? 2/3. Or, yes, another way, I think I'd be 50-50 about what I would do. Yeah, you could make it, you don't know what it equals, so you make it 5 to the question mark is equal to the cube root of 25. You need to recognize powers instantaneously. Your goal is to make things, reduce them to their power form. What is 25? So you have 5 to the question mark equals 5 squared to the 1/3. Sorry, that's a question mark, not a 2. So what do you end up with? Question mark is equal to? Either way, there are many paths. Can you make these as hard as you want? Pretty much.
I looked at when you did the exponential where...
Is that a pencil or a pen? Please use a pencil.
I used a pencil on the
Oh,
homework.
okay, go ahead. What's your point?
If you have like the x root or the n root of x to the m
Yeah.
is equal to...
The nth root of x to the m is equal to the nth root of x to the m.
Yeah.
To the m, not 1/5. To the m. Yes, you can do that. Yeah. Again, how many paths are there? There's tons. Whatever you're most comfortable with. Just do the one that's clearest to you. Please don't skip steps. It takes an extra like 2 seconds to write out each of these steps, and it ups your chance of ending up in the right place by a lot. Don't make it harder than it is, but just be careful. One last, they write this kind of as an identity. It's just something, it's kind of I call it a neat result. You'll see something like this. What does that equal? It looks pretty complicated. Overall, is that an exponential or a logarithmic equation? Exponential. It is an exponential equation with a logarithm in it.
It takes 1 step at a time.
I understand, but what I'm saying is overall this whole thing is an exponential. It just has a logarithm as one of its exponents. If we were to translate that into a logarithmic, the equivalent logarithm, can someone tell me what it would be? Raise your hand and tell me. Log base of question mark is equal to log base a of m. This thing marches down right here, right? This thing marches right there, and the base, where does the base go? The base always stays as the base. So look, you have log base a of question mark equals log base a of m, so what has to be true? Equals m. So up here, question mark equals m. So what did we just prove? We just proved that a to the log base a of m is equal to m. You will see this all the time. So one easy way to make log equations look more complicated is to throw something like this into it. Reduce it. Get rid of it. Make it more simple. Any other questions from homework 12?
25.
25?
Oh, no, I got it. It's just...
Log of 1, no matter what the base, is always what?
1? No. It's undefined.
0.
0.
Log of 1 is always 0.
Okay.
Anything to the 0 power is 1, because we're using non-zero bases. Non-zero bases. In particular, we're using positive bases. The most important questions you need to be able to answer are 25 through 36. Are we good about 25 through 36? Okay.
So ln, can you...
Log base
No,
E.
I got confused.
Which
by
one?
The ln, the
Yeah.
last two.
The last two? Fine. That's easy. They take about... Yep.
Oh, yeah, sorry.
These two? Yes. Yes. So for the first one here, that's just log base 4 of... Log base E of 4 is equal to x. So what's the exponential form? E to the equals. And on this one, it's log base E of x is equal to 4. So E to the equals. Done. That's it. All ln means is log base E. That's all it means notationally. This is the notation. Yes, I like what the Germans do. They like to, they don't like it, but it's common practice. It's log written by itself. What's the base? 10. In other places, when they want base 10, they write LG. It makes sense, but again, how logical are Americans? Any last questions on that homework? So I have a present for you. Same base. What do you do with the coefficients? Yeah. What is that? If log base 3 of x to the 1/2 equals log base 3 of 2 squared, what does that mean has to be true?
X to the half equals 2 squared.
So the square root of x is equal to 4, so x is equal to 16. Boom. Nice and clean.
Boom.
Yes. What else? Any other ones look weird?
4.
4? Let's do 4. 4 actually has the ugliest answer. Now, what form is this in?
Logarithm.
Yes. So what are we going to translate it into?
Exponential.
So can someone tell me what it is in exponential form over here? Yeah.
5 squared equals x squared plus
Now it's just a... hopefully it's factorable, is it? Not nicely. Answer turns out to be, well, b squared minus 4ac turns out to be 85 on this one, where you end up with 0 as x squared plus x minus 21 when you simplify it. It doesn't, I'm racing through this a little bit, I know. I just have somewhere to be. Sorry. The answer turns out to be -1 plus or minus the square root of 85 all over. All I'm doing is using the quadratic formula, guys. Yeah, so the point is, how many new mechanisms did you need to do this question? 1, just the beginning, right? If you didn't know how to go from a logarithmic to exponential, you wouldn't be able to solve this. But you were able to go straight to exponential, but the exponential turned into 25, and then it just turns into a, and then you're, oh, okay, I can do this. Doesn't matter what the quadratic is, can you always generate an answer? Yes. If it's not nicely factorable, you immediately go to done. Calculator. If anybody writes ugly decimals, I just don't like you as much. So please don't write ugly decimals. I want radical answers. Radical answers. Radical. Okay, let's take a look at the next 9. Let's look at the next 9 questions. 7 through 15. I love these questions because they can look visually unbelievably difficult and be so straightforward. The key to these, the thing that makes these most difficult, finding the right place to start. You will go in the wrong direction and have to restart the questions. That will happen. It is unavoidable. Don't keep track of what you're doing. Exactly. Which one do we want? What's the vote?
9.
We're going 7 through 15. 7 through 15.
9.
15? Really? 12? Let's do 12. Log base 4 of x. Again, what's nice about this? Let's see how far we need to go to get to someplace nice. Well, any coefficients other than 1?
I'm sorry, can you just repeat?
Any coefficients other than 1?
No.
What can we do with the plus then? What do we do?
Combine them.
Multiply. So it turns into log base 4 of?
X squared minus 3.
Yeah. Equals? Logarithmic form. Let's turn it into?
4 equals that 4.
What are we at now? Quadratic. Are we home free? Yeah, it turns out to be factorable even. If you actually finish this, and this is important for us to note, it turns into x minus 4, x plus 1. So what are the answers?
X equals 4, X equals -1.
What should you always do once you get your answers?
Check.
Always check. It's really important that you do, because if you go up here and you check -1 in here, log base 4 of -1, well, you do this. 4 to the question mark equals -1. 4 to any power, can it be negative? No. No. So it can't be what? Negative. So, what's your answer? You don't like -1. That is correct. Check your answers. I plugged it into the original question. I plugged it in just to the first part, because even if you could plug in -1 right there, which you can you plug in -1 to log base 4 of x? No, you can't plug it in, because can you raise 4 to a power and get a negative number? 4 to any power will be positive. You can never generate a negative. Okay, that's pretty good. How about, let's see how you handle something. Let's get more interesting here. Ready? How about you pick something out of 19 through 26. We're not going to touch 27 yet.
26.
I'm going to do 25 instead. Ha ha. What do you see? What do you see?
Different exponents of x.
What do you see? What do you see?
It's not logarithm. It's the exponential form.
What do you see?
Logarithm. Multiplication.
What do you see? What do 2, 8, and 4 have in common?
2. And
2.
2x.
When I look at that, all I see is 2. What do I mean by that? 2 to the x. What is 8?
2 times 4.
What is 4?
2 squared.
What do we know about logarithms? Things are much nicer when you have the same base. Same thing with exponents. So if you can, what do you build? The same base. The same base. The same base. Now, what do you do with powers of powers? And what do you do when you have the two bases the same and you multiply? What do you do? Add. So it's 2 to the?
Negative 2x.
2 to the? So if 2 to the negative 2x equals 2 to the 2x, what has to be true? Negative 2x has to equal? So what does x equal? Eh. 0. Plug in -1, it always flips signs. Be careful. Only thing you can do there is 0. So when you look at numbers, you need to see the base. So when you see 27, what do you really see?
3.
3. 3 to the third, right? Not 3 times 9, you want powers. So when you see 64, you see 2 to the 6th, 2 to the 6th. Yeah, it gets fun. Yeah.
Okay, so here, like, before you even mentioned factoring, I kind of just did the exponent structure. Sorry about that.
I have no idea what you just said.
Okay, before factoring, I legit just, like...
I did no factoring there.
Before
I didn't do any factoring in that.
I used to.
I changed. I transformed.
So before changing.
What did you do? You can't touch any of those exponents because they don't have the same bases.
So you can't touch it.
You can't. They can't touch the screw. You can't touch a thing if you have different bases. 2, 8, and 4 are not the same base. You can't multiply. You can't combine exponents. You can't do anything. The bases need to be the same. You need to build them to be, again, the same.
So, but they were multiplying. So if you do...
It does not matter. 2 to the x, what did you do to this? How did you simplify that without changing it to the same base?
16.
Eh.
Come on.
You could be very careful about it, and you could do this. You could turn it into 2 to the negative x to the negative 1 times 8 to the negative x, but then you're still messed up because you have that negative power right there. They're not being raised to the same thing. If you have the same power, it can be done, but same base is by far the easiest way to go. Don't make up rules.
So how did...
So, yeah, go ahead.
Take away the exponent.
How did I take away the exponent? I didn't take it away. I said this, if a to the x equals b to the x, sorry, that's not what I meant. If a to the q equals a to the r, then what? Then q equals r. I didn't take it away, I just used that statement. If
Okay.
a to a power equals a to something else, those two powers have to be The same. It's the same thing we had before. What's the equivalent statement? If log A equals log B, then A equals B. That's correct. Then that's true. They are statements. Are you dividing the log out here? No. These are just true statements.
Alright.
It's really important that you realize that, because can you ever like cross out the log by dividing it out? No. It's the same with sine. Can you like cross sine out? Like you see this, sine x over n is equal to 6. No. 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 I really just need to get a clip from Family Guy to play in those situations. I just need to be able to like click in and go, no! No! Can I narrate my life? Can I narrate my life? No. Okay. Let's go back and look at those questions again.
Family Guy. Wow.
19 through
Watch
26.
Family Guy?
Of course I do. 19 through 26.
24.
24? Okay, when you look at 24, what do you see?
3.
Yes. Good answer. 9 to the negative x equals 1/3. What's 1/3?
3 to the negative 1.
3 to the negative 1. What's 9?
3 squared.
So you get 3 to the negative 2x equals 3 to the negative, nope, 3 to the
Negative 1. Negative 1 equals
negative 2x equals negative 1, so x is equal to 1/2. Done. If you recognize the common basis, things get real easy. I will tell you this, though. Once you get started and generate momentum, you'll be able to crush these. The stumbling block usually becomes right at the beginning. Happens right at the beginning. If you don't see the starting point, and you won't necessarily recognize it if it is the right starting point, you're just going to have to try stuff. But the basic idea is the smaller numbers are your friends. The bigger numbers are not. That's generally true with all of math, I guess. Except in some fields. Yeah.
I just find this in the beginning of the problem.
Except in finance.
Except in finance. That's true. You could stick up someone for 20 bucks and go to prison. You could stick up someone for $20 billion and go away for 10 days. That's... yeah. Wait, it's kind of true. Yeah.
What happens if you can't make the basis?
Ah, then it's really fun. So, you'll notice in the higher up problems, you'll see things like this.
It reminds me of those old movies from prison. They used to draw Bugs Bunny and they would erase things for years.
Something like that. That's what you're going to have to figure out. The only thing I'm going to tell you is I'm going to give you one helpful thing. You're not going to have to tackle that until probably tomorrow night, and we'll talk about it tomorrow in class. You're not going that far on this sheet. Here, it's really quite simple, actually. If A equals B, then log A equals log B. You can add logarithms in to attack exponential problems. Think about that. We're not going to go into it right now because I have to take a look. No. So...